Hello, good afternoon. My name is Riley. This week we're covering Chapter 7, Territoriality and Migration. I focused on the subsection To Stay or Go, specifically dispersal, from page 235 to 239. A key concept of this section is natal dispersal patterns, which are usually sex-biased, with male-biased dispersal being seen mostly in mammals, and female-biased dispersal mostly in birds. A vocab word we'll be using a lot is philopatry, which refers to an individual being faithful to their natal group or area, so they don't leave their birthplace. On the other hand, natal dispersal is when an individual or a group disperses prior to sexual maturity to explore different habitats. Currently, it is widely accepted that inbreeding avoidance is a huge driver for female natal dispersal, where male philopatry may be driven by mating strategy, mate competition between male kin, and kin cooperation. The inbreeding avoidance hypothesis is seen to reduce inbreeding depression, which can have a severe fitness cost on a population, but male philopatry is not as widely studied or understood. My primary literature addresses this lack of research and is titled The Evolution of a Rare Mammalian Trait, Benefits and Costs of Male Philopatry in Proboscis Bats by Gunther et al., 2017. The neotropical proboscis bat was perfect for this study because it is one of the few mammalian species that consists of both philopatric and immigrant males, allowing researchers to explore possible costs and benefits between these two dispersal methods. Our main research question is what drives the evolution of male philopatry in mammals. The proboscis bat lives in Central to Southern America in social colonies of up to 50 individuals with equal number of male to female. They'll occupy exposed tree trunks, branches, vines, or man-made structures, and have 2 reproductive seasons, one in October to November and one in April to May. Some males develop territorial mating systems for resource and female defense. One exception to this behavior is driven by high predation risk during the daytime, which drives males to be less territorial in order to form cohesive roosts within a single male's territory. The species displays mostly female-biased dispersal, where all female offspring disperse from the natal habitat by an average of 38 days old. Some males will also disperse at a similar age to other colonies, but about half of the males settle in the natal colony, becoming philopatric. On average, about 83.6% of adult males in a colony are philopatric. During this experiment, researchers focused on 3 different colonies labeled C5, RS, and CG. These groups of bats were misnetted in their roosts, genetically sampled, individually marked with colored bands, sexed, measured, and classified into age groups. Overall, there were estimated to be more individuals sampled than banded due to the exclusion of pregnant, young, or poor-conditioned individuals. Researchers used several different methods to classify variables and results, including census observation, behavioral observation, census analysis, behavioral analysis, and kinship analysis. Census observation was used to determine the number of unbanded bats and the motherhood of pups. Census analysis was used to determine the age of disappearance of individuals either dying or dispersing into another colony. It was also used to determine minimum male tenure, which directly correlated as a proxy for success of long-term integration. A male in a population was considered philopatric if they were past the average female dispersal age or were directly related to a current colony member. Males were classified as immigrants if they left the natal colony or were related to a bat in another colony. Males were classified as territorial if they had a high fidelity for a specific site in the roost during nighttime hours, and classified as non-territorial if they were absent from the roost at night or switched sites frequently during that time. Behavioral observations were mostly done during the daytime, of any and all visible behavior interactions. During the night, observations were only made within the roost because of variable movement and accessibility to the site. Behavioral analysis was used to differentiate between classifications of behavior, including copulation attempts that were rejected by the female, and agonistic male-to-male interactions. Kinship analysis was used on nursing mothers to track their offspring, and help in parentage analysis. Results were concluded by using a combination of long-term behavioral observations of the individually marked proboscis bats and genetic parentage analysis to assess the consequences of male relatedness structure. Results include that there was no evidence of kin cooperation in the context of mating behavior, meaning that it's unlikely to be a factor for philopatric evolution unless it was on a cryptic level. Additionally, immigrant males had significantly smaller forearms, third and fourth fingers, which resulted in overall decreased fitness compared to philopatric males. Philopatric males also had longer minimum tenure within a colony, having a median of 2.07 years compared to immigrant males with a median of 0.21 years. This difference in integration success was likely caused by immigrants often getting attacked by resident males. The study showed that long-term residency was essential for attaining territory, and the attainment of territory increased overall fitness. The average tenure for a bat to become territorial was about 1.73 years, but the average immigrant male could only sustain a tenure of 76.7 days. Despite this result, the probability of becoming territorial was not statistically different between philopatric and dispersing males. For reproductive success, however, the mean individual reproductive success per mating period was significantly higher for philopatric males, with colony offspring fathered by resident males having longer reproductive tenure as well. Analysis of genetic parentage revealed that the number of closely related competing males was relatively low, with an average of 80.3% of males within a colony being distantly or completely unrelated. In conclusion, the majority of the males within a colony are philopatric and reproducing, benefiting from better integration and longer reproductive tenure, where immigrant males faced many hurdles driven by resident aggression. Overall, philopatry was maintained because social groups of unrelated females were in high proportion to unrelated or distantly related males, and colonies were supplemented with a small degree of successful male immigration. When studying the effects of interbreeding depression, a common cost factor is local mate competition, which lowers a male's overall inclusive fitness. But only 21.5% of competing males were close in kinship, creating a comparatively low LMC factor that was more readily outweighed by the benefits of staying within the natal group for longer. This effect is most likely driven by philopatric males' competition for access to females through the use of direct female defense mating strategies. My secondary literature was a review of the theory sex-biased dispersal. Researchers asked this question because the decision to leave or stay and reproduce in a natal group has fundamental effects on the individual's life as well as the genetic and social structure of societies. There's currently a gap between the empirical and the theoretical literature, with the empirical literature saying that patterns of sex-based dispersal are driven by mating systems, female-biased dispersal often being seen in monogamous birds, where male-biased dispersal is seen in polymammals. The theoretical literature sees patterns of immigration and emigration change the relatedness patterns and alter competition for limiting resources instead. Most significantly, reproductive success. This type of limiting resource is often sexually distinct, so breeding sites or fertilizable females. So how does this affect what we thought we knew? For one, the factors for selecting dispersal most notably are kin competition, inbreeding avoidance, and spatiotemporal variation in resources or habitat sustainability. The study on bats showed that there was no significance in the results for kin competition, And though inbreeding avoidance is often a main driver, because philopatry is consistently associated with prolonged male breeding tenures that exceed the age of the female's first conception, but because of the social dynamic of philopatric and immigrant males within the bat colonies, this didn't seem to be as important of a driver either. Proboscis bats displayed a colony with simultaneous presence of several generations, without increasing the cost of local mate competition. This kind of social structure so far has only been shown in highly social primate species. This highly contrasts with the popular idea that dispersal of one sex often depends on how much the other sex disperses. So further research into the field definitely needs to be done. Some key points that were discussed in Chapter 7 include the cost-benefit approach, which is a way to make sense of behavioral diversity when animals select places to settle and then defend those areas against intruders, or decide to leave rivals alone. This choice behavior is exemplified in the behavior of roost sharing in bats from day versus night, where male bats are less territorial spatially during cohesive day roosts, although they still defend females actively. This slight shift in behavior is an example of a cost high predation risk outweighing the benefits of being overly territorial during the day. Additionally, the concept of dispersal is often referring to permanent movement from a natal area or a birthplace, but proboscis bats are unique in that they have both philopatric and immigrant males interact within the colony, and males are shown to immigrate during various age classifications throughout their life. Some of the highlighted costs within the chapter are classified as energetic, risk, time, and opportunity. Energetic costs include requiring extra energy for travel, and this is seen in immigrant bats by their lower physical fitness, creating a competitive disadvantage. Risk costs are often classified as vulnerability to predators due to unfamiliarity of new habitats. This is seen in proboscis bats by their lack of familiarity with the resource distribution in their new habitat, which can in turn decrease feeding efficiency. Time costs can prevent investment into other activities. In this case, immigrant males show lower reproductive success because they are unable to achieve the tenure that philopatric males often do within their colony. Opportunity costs are the last classification, resulting in lack of selection for the best habitat. For proboscis bats, the presence and familiarity with night roosts can enhance the chances of taking over territory from philopatric males that immigrant males often miss out on because they rarely share the same roosting territory at night due to aggressive advances from resident males. Overall, our takeaways are dispersal methods are often sex-biased, driven by a variety of factors. The decision to stay with a natal group or go off to a new habitat can be assessed using cost-benefit approach, which will weigh the overall fitness potential with the interactions of these factors. The interbreeding hypothesis is used to describe the avoidance of interbreeding depression that ultimately lowers fitness and can be one of the most powerful drivers to sex-based dispersal behaviors. And in the end, the evolution of philopatric or sex-biased dispersal is still widely unknown across species.